Okay, today we're finding square roots. Basically, a square root is the opposite of a square, and a square is the second power. So, if we were to say 4 squared, we would know that equals 16. It's 4 times 4. So what we want is a reverse operation. We want something that takes us from 16 back to 4. Okay? We square 4 to get 16. What takes us from 16 back to 4? And the answer is, I already gave it to you. The answer is the square root. The square root of 16 equals 4. Now, that symbol over the 16 is called a radical symbol. Now, not like back in the 80s where radical meant cool. Yeah. Like those hammer pants are radical, man. Not like that, okay? You guys probably don't know what hammer pants are. Ask your parents, okay? So that symbol is radical, and then what's underneath it is called the radicand. Radicand. So we got the radical covering the radicand. Radical, radicand. Radical is the symbol. Radicand is what you're taking the square root of. Okay? And so when we're taking the square root, we're finding a number so that when we multiply that number by itself, we get our radicand. Okay? Now, sometimes our radical will have an index. It will have a little number in that little gap right there. If we're going to write one for square root, it's a 2. Okay? But for a square root, we don't have to put the 2 there because if there's no number there, we assume it's a 2. Kind of like if I'm using the variable x. If there's no number in front of it, I assume it's 1x. Okay? If it has to be some other number of x's, I put a different number there. With the square root, if there's no number there, I assume it's the square root. Okay? So if I put a different number there, like 3 or 4, that would be a different root. But we're not going to get to those today. Yes, we're not going to get to those today. So, this might help a little bit. Let's see. The square root of 16 equals 4. We just said that. But I'm going to write this as a whole sentence. Because 4 to the second power equals 16. That's what defines the square root of 16 being 4. The square root of 16 equals 4 because 4 squared equals 16. Square root of 16 equals 4 because 4 squared equals 16. Now I'm going to introduce one more symbol to you. That. It's a plus minus. Or plus or minus. We're going to introduce that here and we'll explain a little more as we go on into algebra why and when we use that. So we want to find the positive and negative, the plus and minus, the positive and negative square roots of 36. So what is the square root of 36? David? 6. And so the positive and negative square roots of 36 are positive and negative 6. Because 6 times 6 equals 36, or 6 to the second power equals 36. Now, if we don't have that plus or minus symbol there, then our answer shouldn't have that plus or minus symbol. So if we're just given radical 49, what would radical 49, or the square root of 49, equal? Seth? 7. Because 7 squared is 49. Make sense? Or if we have a negative in front, negative square root of 4, what would that equal? Yana? Negative 2, because 2 squared equals 4. Everybody okay with that so far? Okay? Now, if our square root is an integer, okay, remember integers are whole numbers, positive or negative, they're the numbers you're used to counting with, and all of their negative versions, those are integers. If the square root of our number is an integer, we call that number a perfect square. For instance, 36 is a perfect square because its square root is 6. 49 is a perfect square because its square root is 7. Can anybody give me an example of a number that would not be a perfect square? Sarah, pick a number. 2.5. Okay, 2.5 is not a perfect square because its square root is not an integer. Okay, can somebody give me an integer that's not a perfect square? Emily. 27. 27 is not a perfect square, so its square root is not an integer. But that doesn't mean we can't figure out what it's close to. So 27 is between two perfect squares. Okay, what perfect squares is 27 between? What would be a perfect square that's just smaller than 27 and one that's bigger than 27? Seth?
24 and 36.
Is 24 a perfect square?
Yes.
What's the square root of 24? No, that's half of 24. So you were right. 36 is bigger. What's the smaller one, Bethany? 25. Okay? 25 is 5 squared. 12 squared would be 12 times 12, which is 144. So we've got to be careful not to divide by 2. We made that mistake when we were squaring in chapter 1, too. You don't multiply by 2, you multiply it by itself. Now, 27 is between 25 and 36. That means the square root of 25 is, or the square root of 27 is between the square roots of 25 and the square root of 36. What's the square root of 25? 5. What's the square root of 36? 6. So the square root of 27 has to be somewhere between 5 and 6. Which number do you think it's closer to? Yana, you have a question? Okay.
Maybe 5.5.
Okay, 5.5 might be a little much, but it's a good guess. Yeah?
5.3.
Maybe. Which is it closer to, 5 or 6? Why 5?
5 is 25. And 25 is obviously closer.
25 is closer to 27 than 36 is. So since 27 is closer to 25, the square root of 27 is closer to the square root of 25. That makes sense? Okay? So the square root of 27 is close to 5. Okay? So part of your homework will be to approximate the square root to the nearest integer. What's the closest number to it? So you don't need your calculator, you need this process right here. And so we'd say that since 27 is closer to 25, then the square root of 27 to the nearest integer is 5. It's not exactly 5, but it's near to 5. Let's look at example 2. It says the top of a folding table is a square whose area is 945 square inches. Approximate the side length of the tabletop to the nearest inch. So a square, we know all side lengths are the same, right? Let's call them S. And we know the area is 945. Right? And the area of a square is the side length squared. That means that the side length must be the square root of 945. That makes sense? If we're going to get the area by multiplying one side length by itself, and we get 945, then the side length is the square root of 945. Now they want us to figure out what the approximate value of the square root of 945 is without using a calculator. So let's think about what it could be. Where would the square root of 945 be? It has to be sandwiched between two perfect squares. We've got to figure out what they are. So somebody give me an estimate of what they think the side length of this table might be. Yeah. 900 times 900 would be way more than 945. Yeah.
30. No, 30.
30. Okay, what's 30 squared? What's 30 times 30? 900. That seems pretty close. So that's smaller than 945. Okay, let's look at the next number up. 31. What's 31 times 31? Oh, don't use your calculator. Do it out by hand. What's that? It's not 931, no. 961. That's bigger than 945, right? So 945 is sandwiched between the two perfect squares, 900 and 961. What's that?
That just doesn't make sense.
Catch up. There we go. Sometimes it needs a little prompting to move ahead. So the square root of 945 must be between the square root of 900 and the square root of 961. And what's the square root of 900? 30. And what's the square root of 961? But which must the square root of 945 be closer to? David? Not 30. That leaves one option. Why is it closer to 31? What's 945 closer to? Is 945 closer to 900 or closer to 961? 961. So that means the square root of 945 has to be closer to the square root of 961. So the square root of 945 is close to 31. So the side lengths are approximately 31 square inches. That makes sense? This is going to create a new type of numbers for us that we're going to look at in the next lesson, or the next part of this lesson, called irrational numbers. Are there any questions? Okay.